Hello everyone, I'm Shi Yang. Today I will introduce decision tree. So decision tree is a very popular classification or regression model. And in computer vision, we can use that to do pattern recognition. So what is decision tree? Decision tree is a flowchart-like structure. We can look at the example in the slides here. This is the decision tree for play tennis. So each internal tests an attribute. We can see that there are three attributes: outlook, humidity, and wind. Each branch corresponds to attribute value. For example, the outlook attribute has three values: sunny, overcast, and rain. Each leaf node assigns a classification. For example, we look this leaf node. This is no, that means we will not play tennis. So outlook is sunny and humidity is high, we will not play tennis. So now I will introduce the decision tree algorithms. There are a lot of algorithms to build top-down induction of decision trees. The very popular one is ID3. ID3 uses categorical attributes, and it is used for categorical targets. And another one is CART. But now we just focus on ID3 for classification to calculate information gain. So before I go through the information gain, I will introduce a very important concept: entropy. So what is entropy? Entropy measures the impurity of a set of events. We can look at the formula here. This is Hx. Hx equal to the sum of the events, minus the probability of xi and times the log probability of xi. So the entropy may be viewed as the average uncertainty of the information source. If the information source is homogeneous and has no uncertainty, the entropy is equal to 0. That means the pure site. And if the information source is uncertainty, the entropy is higher than 0. That means the impure site. So we need to minimize our entropy. Then I will go through the information gain. The information gain is an entropy-based measure to evaluate features and produce optional. So this is the formula for information gain. We can see that information gain equal to entropy S minus the sum of the values is a element of the set A. So A is the attribute. That means every values in the attributes should be calculated. This is a ratio of this value and times the entropy SV. Yeah, you can see that S is the set of examples we want to split, and SV is the subset of examples which the attribute value is equal to V. So here we need to maximize the information gain, which means that it gives a larger expected reduction in entropy. Now we look at the example, as I mentioned before, the decision tree for play tennis. So we can see that there are 40 training examples. There are 4 attributes and 1 target. So we just focus on the targets at first. There are 9 positives and 5 negatives, right? So now we need to find the root node of our decision tree. So we calculate the entropy first. The entropy, we use the the formulated before, is equal to minus the ratio times the log ratio. This is the ratio for positive and this is the ratio for negative, and then we get the results 0.940. Then we use that to calculate 4 information gain because we have 4 attributes. For example, we just focus the wind first. For wind attributes, we can see that there are 2 values of wind, weak and strong. And if we just focus on wind equal to weak, we can say there are 1 negatives, 1 positives, 1 negatives, 2 positive, 1 negatives, 3 positive, 1 negatives, and 3 positive, 2 negatives, 4 positive, 2 negatives, 5 positive, 2 negatives, 6 positive, 2 negatives. For example, we read here, and for strong, is 3 positives, 3 negatives. The similar, yeah, it's very similar to I talked before. Then we calculate the information gain for wind. It's equal to the formula for the information gain, and we can see that the entropy S is, we just calculated before, is this number, right? 0.940, and minus the ratio of weak, right, times entropy as weak, minus the ratio of strong times entropy as strong. Then we get the result 0.048. Remember that we need to find the maximum one. So we calculate the 4 attributes, and then we find the maximum one is outlook. So we choose this attribute as our root node, right? Is here. Oh, it's very obvious that if the outlook equal to overcast, we just have 4 positives but no negatives, so that's a pure sign now. That means we will go to play tennis. But for the sunny and rain is impure, is also impurity. So we need to continue to calculate. For example, we expand this now. We can just focus on the outlook equal to sunny, and we remove other rows. Firstly, we need to calculate 3 attributes, 3 information gain for these attributes: temperature, humidity, and wind. Because we already get outlook now. For example, just focus on humidity. Humidity has 2 values now, high and normal. For the high, we have 3 high training examples, but there are no. All of them are no. So there are pure side. The entropy equal to 0. The entropy of normal equal to 0 also, because we have 2 normal training size, but they just predict yes. Yeah, so for the information gain, we also use the formula like I mentioned before, the ratio times 0, ratio times 0. So the result is 0.97095, right? Similarly, we can expand here. So this is the results we get for our decision tree. We can see that if the outlook is overcast, we will go to play tennis. If the sunny and the humidity is high, we will not. But the humidity is normal, yeah, we will go to play tennis. That's great. Now I just short mentioned, the advantages and the disadvantages of decision tree. So the advantages is easy to interpret and can handle both numerical and categorical data. And it can handle outliers and missing values. It gives information on importance of features. But it tends to overfit, But we can use pruning to avoid overfitting. So thanks for watching.